everyone. So today we will be discussing operator precedence and associativity. In our last lecture, we have already discussed the types of operators and various different types of operators. So in this lecture, we will be discussing about operator precedence and associativity. So what is actually operator precedence? We have already discussed various types of operators. What were all those operators we have discussed? Assignment operators, binary operators, increment, decrement operators. So we have already discussed about all these types of operators, like relational operators, all these types of operators, like what are the relation between two operators, less than, greater than, equal to, and all such operators we have already discussed. We have discussed logical operators, we have discussed binary operators. So today we would be discussing about operator precedence and associativity. So whenever we have an expression, then how to evaluate that particular expression, which operator has higher precedence and which operator has lower precedence. This is all about, today's lecture is all about this. So what is operator precedence? It dictates the order of evaluation of operators in an expression. So basically the order of evaluation is to be taught in today's lecture. And what does associativity means? It defines the order in which operators of the same precedence are evaluated in an expression. So we can say associativity can either be from left to right or right to left. Suppose we have an expression like 5 plus 2 multiply 4. So this is a different operator and this is another different operator. So see, these are operators and these are basically the operands. So operator precedence, it actually dictates the order of evaluation of operators in an expression. So what is the order of evaluation? Which operator is to be evaluated first and which operator is to be evaluated next would be discussed in operator precedence. And whenever we talk about associativity, it tells actually if we have an expression which has same operators twice or thrice, let us say 5 plus 6 plus 7. So which operator? So we have plus operator, addition operator twice. So here associativity, it tells that it actually tells this, it actually evaluate it actually evaluate whether we have to evaluate from left to right or right to left. So which left addition or right addition will be evaluated first. So this is what associativity tells about. So we can say that it defines the order in which operators of the same precedence are evaluated in an expression. So associativity can be either from left to right or from right to left. Let us take an example. 25 plus 5 into 4, multiply 4. So it could either be 25 plus 5 multiply 4. Either it could be like 25 plus 5, 30 into 4. The answer could either be 120 or it could have been like this. 25 means we can evaluate 5 into 4, 20 plus 25, or the answer could be 45. So answer could be any of these. So which is the correct answer? This is evaluated. This is taught in operator precedence and associativity. See, what is actually precedence and associativity of operators? There are various rules of associativity and precedence of operators, and they actually determine precisely how each and every expression are operated. So in this expression 1 plus 2 into 3, the operator star, it has higher precedence than addition. So we can say multiplication operator and addition. So this has higher precedence and this has comparatively lower precedence because multiplication is to be performed first. So this is why in this expression 1 plus 2 star 3, multiplication would be performed first because it has higher precedence, and then later on addition would be performed. So this is how we evaluate these. So the answer of this this expression 1 plus 2 star 3 is 1 plus 6, that is 7, not 9. So if we are taking 1 plus 2 is 3, 3 into 3 is 9. So the answer of this expression would be 7 instead of 9. So this is how we can say, we all know the mathematical BODMAS rule. Whenever we used to evaluate all the expression via BODMAS rule in mathematics, we all know that multiplication has higher precedence than addition and subtraction. And first of all, we evaluate the brackets, then off, then division, then multiplication and addition and subtraction. Similarly, there is a precedence. There are some rules of associativity and precedence in C programming language as well. See, associativity of operators, when two operators, they are placed in proximity in an expression, they have the same precedence, and their associativity is used to determine how the expression is evaluated. So whenever the operators are placed in proximity and they have the same expression, so suppose we have an expression A star B divided by C star D. So we have to evaluate which, we know multiplication has higher precedence. We know, suppose we have addition. So we know that multiplication has higher precedence than addition. So here associativity actually tells which multiplication is to be evaluated first, the left one or the right one. So this is what associativity is. So in this expression, 6 divide 2 into 3, here we know that division and multiplication, they both have same precedence, and addition and subtraction, they both have lower precedence. So in this expression, when we see addition and multiplication, since we know they both have same precedence, so which have to be evaluated first. So in multiplication and division operators, this associativity is from left to right. So when we have two operators of same precedence, then we actually evaluate it as per the associativity rules. So this expression will have 9 rather than 1. So 6 by 2 star 3. So here it is like 6 divided by 2 is 3 star 3. So the answer would be 9. So we won't evaluate it in such a way. Suppose 6 divide 2 star 3. First of all, we won't multiply 2 star 3, 6. 6 divided by 6 is 1. No, because we know that associativity here is from left to right. So I'm again repeating, multiplication and division have since the same precedence, so we will evaluate it from left to right. So first of all, the left one would be evaluated and then the right one would be evaluated. So this is how things will go on. Next this is basically the table of associativity and operator precedence. So first of all, from top to bottom, we have defined all the precedence. So if we have an expression which has brackets and postfix operations, which have all these operations, then we will evaluate first these. And first of all, the topmost operator precedence is actually postfix operator, and then unary operators. After that, multiplication, addition, we have already read about multiplication has a higher precedence than addition. And then shift operators, they are basically the binary operators. Relational operators, we all have studied about all these operators in our last lecture. Equality operators, bitwise and, bitwise or, all these are binary operators. And logical and, logical or, conditional, assignment and comma operators. We have not discussed comma operator, I will discuss it here only. So basically, whenever we talk about comma operator, so basically, suppose if we have an expression A is equals to 2, 4, 8. So this comma operator, it has an associativity from left to right. So first of all, A has a value 2, then A has a value 4, and then A has a value 8. So the most right value would be assigned to A variable. So this is what is comma operator. We have already discussed about assignment operators, addition, assignment, subtraction. So first of all, simple assignment, addition, assignment, subtraction, multiplication, division, modulus, right shift, left shift, and, or, XOR, bits, or. Clear? And conditional operator, this is also known as ternary operator. We have already discussed about this. See, when we read about operator precedence, I'm again repeating. So here, this is a table from the topmost operators have the higher precedence and the lowermost operators have the lower precedence. So we can say all the postfix operators has the highest precedence and the comma operator, it has the lowest precedence. So whenever we talk about this associativity, suppose we have an expression which has various postfix operators, then we will evaluate it from left to right. And we can see only the unary operators and conditional and assignment operators, these operators, they have the associativity from right to left. Otherwise, all other operators have associativity from left to right. So we can say the unary operators, the conditional and ternary operators, and the assignment operators, they have the associativity from right to left. Otherwise, all other operators have associativity from left to right. So this is all about this is all about operator precedence and table. So basically, this table specifies everything. This table has everything. So let us move to the next slide. Yes, parentheses and the order of operations. How the order of operations would be evaluated? Suppose expressions inside parentheses, they are evaluated first. See, if we check our last slide. So first of all, see, we can see the highest precedence is of postfix, and first of all, the brackets will be evaluated. First of all, the parentheses would be evaluated. So all the expressions which are inside parentheses, they would be evaluated first, and this provides for the use of parentheses to clarify or change the order in which operations are performed. So by this we understand that yes, in which order the operations would be performed. Suppose we have an expression this 1 plus 2 star 3, if we evaluate it, see, because we know multiplication has higher precedence and addition has lower precedence. So as per this, first of all, 2 into 3, which is equals to 6. So 1 plus 6 is equals to 7. But when we put this in parentheses, then we have higher precedences of parentheses. See, we can check in your last slide. We have highest precedence of parentheses. So first of all, the parentheses would be evaluated, and then the multiplication. So first of all, the parentheses has 1 plus 2, which is equals to 3, and after that the other operators would be evaluated. So 3 into 3 would be 9. So both these expressions have the correct value. So we understand that parentheses has the highest precedence. So first of all, we have to evaluate the parentheses, and then the order of operations would be evaluated. Now let us move to another one, which is binary plus versus unary plus. See, whenever we talk about binary in our last lecture as well, whenever we talk about binary itself means means 2. So when we talk about binary basically has 2 operands. See, 2 operands. And whenever we talk about unary means it has only 1 operand. So if we talk about addition, binary addition, so binary plus means A plus B, and unary plus means either plus A, either minus A, all these are unary plus. So basically the operand is applied on 1. So basically the operator is applied on 1 variable or 1 operand when we are talking about unary. And when we are talking about binary, it means actually the operand is applied on 2 operators. So same is true of binary and unary minus sign and plus sign, they both have same. So unary plus and minus have higher precedence that binary plus and minus, and the unary operators associate from right to left instead of left to right. Let us check. See, unary operators, where are the unary operators? See, unary operators, they have the highest precedence and as compared to the binary operators. See, these are the binary addition. So unary has highest precedence, and unary has we have already discussed only the unary operators, conditional and assignment. Unary has right to left associativity, and binary has left to right associativity. Clear? So unary plus and minus, they have higher precedence, yes, and the binary binary plus and minus and the unary operators, unary plus and minus have higher precedence than binary plus and minus, and the unary operators, they associate from right to left. Yes, unary operators and relational operators and ternary operators, they have unary operators and assignment operators and ternary operators, they have right to left precedence. See, unary, assignment and ternary operators, they have right to left precedence, and otherwise all other have left to right precedence. I hope this is clear to everyone. See, examples of some unary operators in the expression minus A star B minus C. So this is actually unary operator and this is actually binary. So we can say this minus sign is of unary and this minus sign is of binary. So this is the difference between unary and binary operators. So yes, the first minus is of unary and the second is of binary. We can also use parentheses to write an equivalent expression that is slightly likely to be misinterpreted. Yes, we can write the same expression in this way: minus A star B minus C. So put this in a parenthesis and put this in another parenthesis and put this entire in another parenthesis. So this is how it could be evaluated. Yeah. Now let us take an example. See, we all know, first of all, let us just rate this as per the operator precedence. We all know we have 3 operators here. In this example we can check we have 3 operators: plus, multiplication and minus. So multiplication and division, it has higher precedence than plus and minus, so this would be evaluated first. Later on, plus to minus, so we know that plus to minus, they have left to right associativity, so then this would be evaluated, and in the third number this would be evaluated. So 12 divided by 4 would be 3, yes, and 3 plus 34 would be 37, yes, this is correct, and minus 45, and the answer would be 8. So this is how things would be evaluated. So we will actually, first of all, we can number it in such a way that yes, first of all, the division would be evaluated, and then if plus and minus, they are of same precedence, so we can number it in such a way. First of all, because we know plus and minus, these operators have left to right associativity, so first of all, the left operator would be evaluated, and then the right operator would be evaluated if they have the same precedence. So this is how it would be evaluated. We have another example as well. Yes. Let us say in these we have these operators plus, minus, division, less than, and plus 1. See, so we know that division has the highest precedence. So first of all, the division would be evaluated, and after that plus minus have precedences. So plus, minus, and this plus. So basically, this associativity, the plus, minus, and plus, they all are of same precedence. So we will evaluate it from left to right. So on the second number, this would be evaluated. On the third number, this would be evaluated, and on the fourth number, this would be evaluated. Yeah. So first of all, the 4 divided by 2 is 2. After that, 2 plus 3 minus 2, this entire expression would be evaluated, and 3 plus 1 is equal to 4. So first of all, this would be evaluated. 12 plus 3 is 15. 15 minus 15. 12 plus 3 is 15. And here 15 plus 2 is 17. I think there's something wrong. Yes. This should be 15 minus 2, and it is 13. It is 13. And 3 plus 1 is 4. Yes, 13 is less than 4. No. So this condition is false. So for false, we will answer it as 0. And let us move to another slide. Increment and decrement operators, plus plus. Yes, we have discussed in the last class increment and decrement operators. This plus plus operator is actually the increment operator, and this minus minus operator is actually a decrement operators. They are actually unary operators, and they both have the same precedence, and the associativity of these operators is from right to left. I am again repeating, only the unary operators, clear? The ternary operators or conditional operator and the assignment operator, they have the associativity from right to left. Otherwise, all other operators have associativity from left to right. So we can say the increment operators and the decrement operators, they are actually the unary operators. They have the same precedence, and the associativity of these operators is from right to left. So the unary and decrement operators, they can occur in either a prefix or postfix position with different results. Yes, obviously A plus plus and plus plus A, they are two different operators. Yes, they indeed means that the value of A would be increased by 1, but yes, they are two different variables. Suppose we are putting B equals to A plus plus. So first of all, the value of A would be assigned to B, and then the value of A would be incremented. And we are writing B equals to plus A. Then first of all, the value of A would be incremented, and then it would be assigned. So this is how, this is actually post increment, this is pre increment. First of all, the value of A would be incremented, then it would be assigned, and in here, first of all, the value of A would be assigned, and then it would be incremented. So they both could have, so the prefix and postfix unary operators may have different result. Now let us move to prefix versus postfix when using increment and decrement operators. Let us see each of the expression plus I and I plus plus, they causes the stored value of I to be incremented by 1, we all know. However, the expression plus I, it causes the stored value of I to be incremented. First of all, the value of I will be incremented with the expression, and then taking it as its value, the new stored value of I would be this. So when we are doing this I plus I, first of all, the value of I would be incremented. If I has current value as 5, so first of all, I would become 6, and then then the value 6 would be used as I. And the expression I plus plus has its value, the current value 5, then the stored value is incremented. Yes, suppose I now current value has 7 and we are doing I plus plus. First of all, the value 7 would be used and then I would be incremented. Then the value of I would be incremented. So this is actually postfix and prefix, increment, decrement operators. Let us take an example of increment and decrement operators. Here we have three variables A, B and C. C has initially 0 value. So when we are doing A equals to plus plus C, so first of all the value of C would be incremented. First of all, let us make 3 memory blocks A, B and C. Initially the C variable has value 0. We have initialized the value as 0. Now the expression A is equals to plus plus C. First of all, A is equals to plus plus C. First of all, the value of C would be incremented. Value of C would become 1 and then it would be assigned to A. So 1 would be assigned to A. Then we have an expression B equals to C plus plus. So first of all, the value of C would be assigned to B and currently C has 1. So it would be assigned to B and then the value of C would be incremented on its own. So it would become 2. Now if we print A comma B, so A is 1. So on the output screen 1 is printed, B is 1 and plus plus C. So first of all, the value of C would be incremented and then it would be printed. So C up from 2 it becomes 3 because we have plus plus 3. So 1, 1, 3 would be printed as the output. So we have explained it over here as well. C is incremented, making its, first of all the C is incremented, making its value 1. The result is assigned to A, making its value 1, making the value of A 1 and the value of C is assigned to B, making it 1 and then C would be incremented and finally C is incremented before it is printed, making its value 3. So this is how 1, 1, 3 is printed on the screen. I hope this is clear to everyone. This is pretty quite simple and easy, so I hope there's no problem. Now let us move to another slide. So this is actually practice with operators and expression. Let us take an example. We have initially declared A equals to A, the value of A as 1, B as 2, C as 3 and D as 4. So these are the expressions. So as per our associativity, as per our precedence, I have defined these expressions in parentheses. So we all know multiplication and division, they both have same precedence. So as per associativity, first of all, from left to right, first of all multiplication would be evaluated and then the division. So in this example, suppose A has value 1, 1 multiply, B has value 2 and divide by C has value 3. So 1 into 2, 2 divided by 3, the value would be 0, would be stored as an integer value, right? Because we have discussed int. So whenever we are talking about int, we have not yet discussed the programming or we have not yet discussed the data types, but let me give you a brief about this over here. When we are talking about int, see 2 divided by 3, we all know when we are dividing 2 by 3, the output would be something like 0.6. 26, right? It is 0.6 something. So here we have to grab only the integer value. No, we are not going to work over the float value or the decimal value. So as per, because we have defined all these variables as integer variables, so we would only be working with the integer value, not the decimal, not the float value. So output of this statement or this expression would be 0. I hope this is clear. Now let us take another expression. The expression has operators multiplication, modulus and plus. So as per the associativity, we talk about associativity. First of all, this would be evaluated and then this and then this. So yes, I have put these in parentheses. As per the associativity, let us say A has value 1, 1, star B has value 2, modulus C has value 3 and plus 1. So A star B, A into B means 2 modulus 3 plus 1. So this is actually, we'll write it over here only, 1 into 2 means 2 modulus 3 plus 1. This will be the expression. And this modulus operator, it actually returns the remainder. It actually returns the remainder. So 2 modulus 3 would be 2 only plus 1. So the output would be 2 plus 1 is 3. So output is 3. So this is how this expression would be evaluated. Now let us move to another expression, plus a, increment increment of a multiplied by b minus unary minus and then c minus minus. So first of all, the plus a, these operators would be evaluated, and then multiplication minus and this. So let us take an example. First of all, the value of a would be incremented from 1, it would become 2, and multiply b has 2 minus, so currently c has 3, and then this value of c would be decremented. So 2 into 2 is 4, 4 minus 3, it would become 1. So here we won't take c as plus 1 because c as 2, because first of all the value of c, which is currently 3, first of all the 3 would be used and then it would be decremented. So we have used the value 3 and then we have decremented it, so the output would be 1, resultant would be 1. Let us take another example. 7 minus, this is actually unary operator. 7 minus b into plus d. So first of all, 7 we will evaluate it in such a way, 7 minus b is minus 2, so we will look at minus 2 multiply plus d, because currently d has 4. So first of all, the value of d would be decremented, it will become 5. So this the output would be 7 plus, and here, so it would become 7 minus 7 plus 2 into 5 and 7 plus 10, the output would be 7. This is how this output would be evaluated. I hope this is clear to everyone. Now let us move to the assignment operators. See, we know C programming, this treats this equal to sign as an assignment operator, and its precedence is quite very low from all other operators, and as you remember, unary, ternary and assignment operators, they have associativity from right to left. So assignment operators, it was coming actually quite low in our operator precedence table. So assignment operator has quite lower precedence, and its associativity is from right to left. There are different forms of assignment expressions. A simple assignment expression is of the form of variable equals to right side. Yes, we have a equals to 7. So this is something. Suppose we have an expression. Let us take an example. X is equals to a plus b minus c. So see, in this expression, first of all, this would be evaluated, then this would be evaluated, and then in the last, this entire value would be assigned. So we can say this assignment operator, this has a pretty low precedence, and value of right side is assigned to variable, and then it becomes the value of assignment expression as a whole. So this is how this would be evaluated. Suppose now let us take another example. Suppose we have a is equals to 12 multiply 5 modulus 3. So first of all, this would be evaluated, and this would be evaluated, and whatever would be the output, then in the end, the assignment operator would be evaluated, and the value would be assigned to the left operator, left operand value, left variable. Assignment expression versus assignment statements. What is the difference between expressions and assignment statements? See, assignment expression, it has no semicolon at the end, and assignment statement does. See, this expression, this basically, this is normally an expression. This does not need to have any semicolon, but whenever we are using assignment statement in C programming, it has to have this ternary semicolon, this ternary operator, this termination operator. So we can use assignment expression to condense a sequence of assignment statements. There are various examples of equivalent code using assignment expressions. See, we have b equals to 2, c equals to 3. And a equals to b plus c. So this is b equals to 2. We can say b equals to 2. This is individual in assignment statement, plus a equals to b plus c. So first of all, b equals to 2 plus c equals to 3, and this entire is equals to a. So they individually cannot have semicolons. This is simple. And when we can use them directly. So a equals to b equals to 2 plus 3, a equals to 5. The value of a would be, current value of a would be 5. Note that assignment statement ends with a semicolon, and expressions, they do not end with semicolon if we are using the expressions inside the statements. There are various other assignment operators, C operators, that combine assignment with other operations. And these are actually considered assignment operators, they have the same precedence, and that is from right to left, and they have the same precedence, and the associativity is from right to left. Suppose we have k is equals to k plus 2. See, so this would be validated k plus equals to 2. So this is quite equivalent to this operator. So first of all, we all know in this equal to this assignment operator and this addition operator, we all know addition has higher precedence. So this would be evaluated and this would be assigned to the variable k. So this is quite equal to this. This is also an assignment operator. So these are all the examples of assignment operator: equal to, plus, equal to, minus, equal to, multiplication, equal to, division, equal to, modulus, equal to, left shift, equal to, right shift, equal to, and equal to, binary and, binary or, binary or, equal to. The semantics of other assignment operators is quite specified, and the semantics is simple. Variable equals to variable operators, like we have j multiply equals to k plus 3. So this is actually expression is equal to j is equals to j into k plus 3. So in this statement, first of all, the multiplication would be evaluated first, then addition would be, first of all, the brackets would be evaluated. So first would be this, second would be this, and third would be this. So this expression is actually equal to this, not this. So first of all, this entire bracket would be evaluated, parenthesis would be evaluated. So this was all about today's lecture. I hope this is clear to everyone. In our next lecture, we will be discussing typecasting and implicit typecasting. So this is all about today's lecture. Thank you very much.